In this demo, we are going to see how we can expose existing REST API as MCP tools using Apigee. The goal is to show how AI agent and MCP clients such as Claude can discover and use enterprise APIs through the Apigee in governed way. For this example, I'm using a weather API. The original backend is regular REST API, but I do not want the AI client to connect directly to the backend. Instead, I want to expose this API through the Apigee and then make selected operations available as MCP tools. The architecture has two important parts. First, we have a regular Apigee API proxy. This proxy represents the real API layer. It receives requests from the client, applies Apigee policies if needed, and towards traffic to the original backend service. In our case, this is a weather API proxy. It routes traffic to the original weather API backend. Second, we have the Apigee MCP Discovery Proxy. This is a special Apigee proxy template that exposes API operations as MCP tools. The MCP Discovery Proxy provides the MCP endpoint that MCP clients can use to initialize the connection, list available tools, and call tools. So, the flow looks like this. The MCP client, for example, Claude, connects to the Apigee MCP endpoint. The MCP Discovery Proxy exposes available API operation as tools. When Claude calls a tool, Apigee maps the tool call to the corresponding API operation. Then regular Apigee API proxy routes the request to the original backend. This means that the AI agent does not need to know the backend details directly. It works with the tools exposed through the Apigee. Now let's look at the OpenAPI specification. OpenAPI file describes the operations that we want to expose as MCP tools. For the MCP Discovery Proxy, every operation should have clear operation ID, because this becomes the tool name that the MCP client can discover. For example, if we have an operation called alerts query, this operation can appear as MCP tool in Claude. There is one important detail in the OpenAPI specification. The server URL must match Apigee environment group hostname where the MCP Discovery Proxy is deployed. So, for the MCP Discovery Proxy, the server URL is not the original backend URL. It should be Apigee hostname. The original backend URL is configured in the regular Apigee API proxy target endpoint. The MCP Discovery Proxy uses the OpenAPI specification to understand which Apigee API operations should be exposed as MCP tools. Let's take a look at our current Apigee setup. We see that we have proxy named Weather API Proxy deployed to the eval environment. It routes traffic to the weather backend. This is our existing REST API layer. In real enterprise environment, this could be any existing API already managed by Apigee or newly created. Before we create or use the MCP Discovery Proxy, we also need to confirm that API Hub is provisioned in the Google Cloud project. Let's go to the API Hub. Here we can also see that Weather API Proxy is already registered in API Hub as our existing API. API Hub is prerequisite for the Apigee MCP Discovery Proxy because it provides a discovery layer where the MCP APIs and tools can be registered, cataloged, and found. Now, I will create the MCP Discovery Proxy. In the Apigee console, we go to the API proxies and click Create New Proxy. For the proxy template, I'll select MCP Discovery Proxy. Then I provide name for this demo. I'm going to use Weather Native MCP Discovery Proxy. This name makes it clear that this is a native Apigee MCP Discovery Proxy for the Weather API. Next, I'll upload the OpenAPI specification that describes Weather API. Then click Create. For this demo, I'm not going to add security. In a production environment, we would normally protect the MCP endpoint using OAuth token or API keys. Apigee allows us to add policies such as verify access token or verify API key at the beginning of the proxy endpoint perform. But for now, I want to keep the demo simple and focus on the MCP discovery flow. Now, I deploy the proxy to the Apigee environment. During the deployment, Apigee provisions the required MCP component. This can take a few minutes. When the deployment is complete, the proxy status changes to the deployed and the MCP endpoint becomes available. Now we can test the MCP endpoint. First, I send an initialize request to the MCP endpoint. This request uses JSON RPC and tells the MCP server which protocol version the client supports. If the initialization is successful, the response confirms that MCP endpoint is active and provides the server information and capabilities. Next, I call the tools list method. The response shows the list of available tools. These tools are generated from operations defined in the OpenAPI specification. So, if my OpenAPI file includes a weather API operation, I should see tools such as ls query here. At this point, the API operation is no longer just a REST endpoint. It is a discoverable as MCP tool. Apigee also automatically registers the MCP Discovery Proxy in API Hub. By filtering the API style as MCP, we can see our weather native MCP Discovery Proxy. This confirms that MCP API is not only deployed, but also discoverable and governable through the API Hub. Now, let's connect these to the Claude. In Claude, I go to the Customize, Custom Connector. I will name it something like Apigee Native Weather MCP. This name is useful for the demo because it clearly shows that this connector uses the native Apigee MCP Discovery Proxy capability. Then I provide the MCP endpoint URL and click Add. You can see, by the way, our alerts query tools. For example, I can ask list the tools available from the Apigee Native Weather MCP connector. Claude discovers the tools exposed through the Apigee MCP endpoint. Then I can ask Claude to use one of these tools. For example, use the Apigee Native Weather MCP tool to get active weather alerts to summarize the result. From the user perspective, it looks like natural language request, but behind the scenes several things are happening. Claude is using MCP to discover and call a tool. MCP request goes to the Apigee MCP Discovery Proxy, maps the tool call to the API operation. The regular Apigee API proxy routes the request to the backend weather API. The response comes back through the Apigee and is returned to Claude. Claude then summarizes the result in natural language. This is the key value of using Apigee with MCP. We can take existing APIs, describe them with the open API, expose selected operations as MCP tools, make them available to AI agents in control enterprise architecture. Later, we can add more enterprise capabilities. For example, we can secure the MCP endpoint with OAuth or API keys. We can apply quotas and traffic management. We can monitor MCP traffic in Apigee Analytics. We can also create API products to package and manage access to these MCP tools. So, in summary, this demo shows how Apigee can help enterprises move from traditional API management to agent-ready API management. Existing APIs stay governed by Apigee. MCP clients discover them as tools. AI agents can consume enterprise capabilities securely and constantly, and organizations can reuse their existing API investment instead of rebuilding every backend as separate MCP server.